So yeah, so that way, like, it's not absolutely necessary for you to always be in the lecture, but you kind of know, since this is a summer class, everything gonna be going pretty fast. So if you do miss a session, you do kind of want to see that session as soon as possible, because you don't want to go like 2 days without seeing it, because stuff that we're going over that day, you're gonna need the information that we went over that previous day. So if you do miss a day, if you actually go to Canvas, if you go right here where it says YouTube lecture link, this is where you can find the video. So right now there is no video because we haven't had any lectures. But all of my lecture, I'll post it on here, and I'll post them based off of the day. So today, YouTube link, it will be called, what is it, June the 15th. All right. Any question in regard to recording? All right, so let's go over the syllabus.
I have a question.
Yeah, what's up?
Sorry, I don't think my video is working.
Oh,
There you go. Hi. Do you have like a specific time frame within that you can join the actual Zoom meetings? Like, does it not allow you to join after like 15, 20 minutes, or can you join late? So I should ask.
Yeah, pretty much you can join at any time. Like if you're 30 minutes late, an hour late, 2 hours late, it will let you join. So once you click on that link, it will let you join. It's not like if you missed that, pretty much the start of it, it won't let you join. It will let you join anytime. All right. Cool. Any other questions? All right, so let's go over the syllabus. All right, everybody able to see the syllabus where it says welcome to Math 227?
Yes.
Or even the baby saw it. Good. All right, so yeah, welcome to Math 227. This should be hopefully a fun interactive class. Like, I love statistics. My master's degree is actually in applied statistics, because I got my master's degree at Cal State Long Beach, and I got it in applied statistics. So I really, really like statistics. I think it's a useful thing, especially nowadays where everywhere you go, they kind of throw statistics at you. So you kind of want to know what are all of these statistics doing, and pretty much you kind of want to know, is this statistic is it a valid statistic or not that valid? All right, so some of the basics. So this is Math 227 Statistic 4 unit, and the section number is 1555. The day that we're going to be meeting up on Monday, Tuesday, Wednesday, and Thursday. The time is 7:30 p.m. all the way to 9:35 p.m. and the place will pretty much just Zoom. All right, so if you do have any questions about anything, homework question, if you have grade question, quiz question, test question, this is where you want to direct your email. So vallejj@wlec.edu. Or you can also just email me through Canvas. If you go to the inbox, and if you just click on, well, you just go to inbox, just send me an email, and that should be good. All right. So my office location, so Zoom, office hour gonna be Monday, Tuesday, Wednesday, Thursday, from 6:45 to 7:20, or by appointment. All right, so that's the class, and that's my office hour. Any questions so far in regard to that? All right. So the course description, we're gonna be learning a lot about statistics. So statistics, we're gonna be going over like, what is a statistic? What is a probability, all the way to going over hypothesis testing, because pretty much statistics is all about hypothesis testing. Just kind of going over like, we have a hypothesis and we want to test out to see if that hypothesis is correct or not. All right. So let's go over the prerequisite. So for the prerequisite, either you take Math 125 or Math 125S, or you pretty much place into 227. So that's how you want to test into Math 227. Either you take Math 125 or Math 125S, or you were placed into this class. So you just kind of know in order to pass this class, you need a minimum grade of a C or better. So you want a C, B, or an A. Or I think you could also change from a pass, no pass class. So in a pass, no pass class, you just want to have a pass. All right, so the textbook that we're going to be using is this textbook over here, Statistic Informed Decision Using Data, 5th edition. So that's going to be the book that we're using, and the author is Sullivan. So whenever you can, try to get that book as soon as possible. So you could, most likely you want to just rent out this book, because I'm pretty sure after this course, you're not going to use this book ever. So just try to get it by renting it out, and that should be fine. Any questions so far? All right. Also, yes and no. So we got a question. No. All right. Also, yes and no, in the back of the book, all of the solutions are there for the on number. So you kind of want to be double checking your solution. The thing is, like, you kind of want to make sure that what you're getting and what the back of the book is giving you, all of that is kind of clicking. So you want to kind of be self-checking yourself. You don't really want to be doing like 20 problem and then all 20 problem are wrong, and you take a quiz or you take a test and then turn out you do it wrong for the quiz and the test. So you do want to be self-checking yourself just to make sure that you're on the ballpark, and also you kind of know. For the solution, it's okay if you're slightly off. So say like in the back of the book, it said it should be 5.37 and you got like 5.31. That's pretty much close enough to the correct answer that you should feel confident that you got it correct. Because you're not always going to get the correct answer, because usually for the back of the book, they use technology in order to get the answer. But if you're doing it by hand, it should be slightly off. All right. So the calculator we're going to be using for this semester is the TI-83 Plus or the TI-84 Plus. So for this one, since we're not meeting up in class, there's actually application on your cell phone that you could get. Some of them are free. I know, like if you have an Android, if you type in this, it will give you a free app that will give you a TI-83. So if you type in Wabitude to the Play Store, I think they call it, it will give you a free TI-83 or 84. But if you have like an iPhone or something like that, you just get an app. Usually it costs like $3 to $5, so it shouldn't be that expensive compared to actually having to buy the actual calculator, which is like $100. So just go to the App Store, type in TI-84, and you should be able to use that calculator for testing for quizzes. Any question in regard to the book or in regard to the calculator that we're using for this semester? All right, sweet. Nope. All right, so app policy. So right now we have 2 space, but I'm usually, you could give that to people who are on the wait list, which I already sent out, because the cap should be 49. So for this one, so we have 2 open space, and I already emailed 2 people who are on the wait list, so these should be getting that pretty shortly. Also, if anything is ever off with Canvas, you do want to just have this kind of handy for you. For that way, you can either email them or you could just call them to let them know something is wrong with your Canvas. So in case you can enter Canvas or something is wrong with Canvas, the class isn't uploading, do you have this information? Do you have that contact information there? For that way you can just email them or contact them by phone. to let them know that something's wrong with Canvas. It doesn't let you enter Canvas or stuff like that. Any question in regard to Canvas support or ad policy? All right, so for the student learning outcome, the student learning outcome is something that we kind of expect everybody to kind of get out of the class that you should know how to do at the end of the semester. So one of the learning outcome is you should at the end of the semester be able to do a hypothesis test. And when we talk about hypothesis test, we're going to be getting into a hypothesis test from chapter 10 all the way to chapter 14. So that's when we get to a hypothesis test. You should also be able to do a correlation coefficient. Correlation coefficient, we'll actually get to that in chapter 4. So somewhere in chapter 4, we should be getting into correlation coefficient. So that's when we'll get into that. And lastly, you should just be able to know something in regard to probability. So just know what is probability and also kind of know in regard to confidence interval. So those are kind of like the three main things that you should be getting off of it. You should, at the end of the semester, be able to do a hypothesis test, correlation coefficient, and lastly, confidence interval. For the first student learning outcome and the third learning outcome, pretty much we're going to get into that once we get into chapter 9 and above. The second learning outcome, this is actually going to come up in chapter 4 and chapter 14. So we'll get to correlation coefficient before 1 and 2. All right, so let's get into the grading system. So for the grading system, you're going to have 4 exams. Each exam is worth 125 points. So if you do 4 times 125, that's 500 points. So if you look at that, those 4 exams, it's going to account for 50% of your grade. All right, next thing that we have quizzes. So for the quizzes, it's kind of, we might get to 11 quizzes, but we might not. So depending on how many quizzes we take, I'm going to keep the highest 8 quizzes. So the lowest 3 or however many quizzes we take, I'll drop them. So say if we only actually do 9 quizzes. If we just do 9 quizzes, I drop the lowest one. If we take 10 quizzes, I'll drop the lowest 2 quizzes. And whatever the highest 8 quiz is, I'll do 8 times whatever your score is. And that's how you get to 200 points. So 20% of the grade will be quizzes. Then we have the final exam. So the final exam is 250 points. So that means worth 25% of your grade. And lastly, we have homework. Homework is 10 points each. So that's 5%. So that's 50 points, which will account for 5%. So the homework will just come directly from the book. So those are how I'm going to grade you for this semester. Any question in regard to any of those or assessment? All right, sweet. All right, so we're gonna pretty much just go based off of the point system because the point system is pretty easy to use. So if you get anywhere from 900 to 1,000 points, that means you got an A in the class. If you got 800 to 899.99 points, you get a B. If you get 700 to 799.99, you're gonna get a C. So that's how you can kind of figure out how many points you have. So that way, like in the final, you can kind of figure out how many points do you need in the final to either get an A, a B, or C, D. I'm pretty sure nobody want to get a D. But that's the way you can be able to figure out like what grade do I need to get in order to get the grade that I want. All right. Any question in regard to the letter grade distribution? All right, so general student behavior. So student behavior, pretty much just kind of, if anybody is talking during Zoom, you kind of give them the respect and just let them talk. Don't try to talk over them. So if I'm talking, don't try to talk over me. If a student is talking, don't try to talk over the student. So whoever's talking during that time period, you kind of respect them and let them ask their question, even how annoying you think that question is or anything like that. Let them ask that question. All right. So for attendance, the way I'm going to be taking attendance, I'm not going to be actually taking attendance during Zoom because I don't want you to think that this is the lecture. Yeah, the lecture is being recorded. I'm not gonna be taking attendance for Zoom because I know stuff happened. I'm not gonna let you come to class on time or every day. So I'm not gonna be taking attendance for Zoom. So you don't have to worry about that. The way I'm gonna be taking attendance is your assignments. So if I see that you have missed 4 assignments in a row, I'm just gonna drop you because pretty much the way I'm grading you is based off of assignment. And that's also showing me that you're participating. So if you're not actually doing the quizzes, the exam, the what else, homework, that's kind of showing me you're not participating, and that's pretty much the way I'm going to see if you're participating. Because I know everybody could like just go to Zoom, open up Zoom, and then just check out of it. So I'm not going to be taking attendance based off of that. It is based off of your assignment. So as long as you're completing the assignment, you're going to be getting credit for attendance. But also, if you do have to miss class or anything, just email me for that way. I still know that you want to participate and are still trying to do it. All right,
Hey, I have a question.
what's up?
Like, how do you feel about late assignments? Can we turn in late assignments or no?
How late are we talking about?
Like maybe a day late or 2 days. I'm not saying like a month late or anything like that. Or actually, yeah, if we missed like an assignment from like a month ago, can we still turn it in?
Usually, I want like homework, probably, but for quizzes, the thing is, I usually like once the quiz is due, I want to be able to post the answers, so that way, because once I pretty much put the posted answer, it's kind of hard to kind of tell you you could do it because now you have all the answer. So if it's like a month late, it's probably not. I'm not gonna allow you to turn it in. So that kind of makes sense.
Okay.
All right.
Thank you.
Yeah, you're welcome. All right. So academic honesty and policy summary. All right. So for this one, it was kind of crazy for the fall semester. Because for the fall semester, I created an exam, and the exam had all the original problem, and somehow all my problem got leaked on the internet. So for this one, I am going to take it pretty serious. So for academic honesty policy, for this one, like I know there's website out there that will do questions for you and will do the problem for you, but the thing is, you're not actually learning anything if you do that. So if I catch like any problem on my online, and like one of the main corporate is check.com, like, well, I'll go over that in a little bit, but for the academic honesty, like right now, like you already have open book, you already have open notes, and you pretty much have like open internet source. But like the one thing I am gonna kind of put my foot down, if anybody posts question online and they just copy and paste it, or do you take a screenshot of the problem and then you let somebody else do it, that's not going to fly in this class because that's not showing you know anything. That show that you know how to copy and paste, and that show how you know how to take a screenshot. But that's really not showing anything skill wise. So for this one, like you have open book, you have open notes, you have open internet source where you could Google like how to do a confidence interval, how to do hypothesis testing. But you actually just blaming it, putting a problem up, and just letting somebody else do that for you, and you get credit for that. That's not gonna fly for this class. All right. Any question in regard to that? All right. So additional resource. So here are the additional resource. Pretty much just me for right now, because I don't know what West LA. Well, I know West LA have NetTutor. So you could use NetTutor. You could just post a question on NetTutor and they'll give you a response. I don't know how fast it will be. It'll probably be faster if you just email me, because if you just email me, I'll be able to get to you less than, I don't know, probably 2 hours, as long as I'm awake. So if you email me with a question about a homework question, lecture question, I will be able to help you out, but just email me. If you do email me directly, just make sure that you put West LA Math 227 on the subject title. For that way, I know it's for this class, because I do teach at other colleges and they do go to the same email place. So if you could put the subject line WLAC Math 227, and that way I should be able to know it's for this class. All right. Any question on how to email me? All right, cool. All right. If you do have some sort of learning disability, please let me know as soon as possible. So that way for quizzes, tests, and for, well, yeah, quizzes and tests, I could give you extra extended time. So instead of just giving you like 75 minutes, I could give you an hour and 50 minutes to be able to complete that test. But in order for me to be able to do that, I do need something from DSPS notifying me to give you double the time or hour and a half time extra. So you do kind of have to go through DSPS and try to get them to just email me that information. So that way I could start giving you that extra time. But I can't really do that unless DSPS send me something saying that, yeah, I should give you double the time or time and a half. So if you do have a learning disability, please let me know as soon as possible. So that way for quizzes and tests, I could post that you should get extended time. Any question in regard to that? All right, sweet. Now. So here are the tests. So the tests are pretty straightforward. Every time we cover 3 chapters, you're gonna have a test on those 3 chapters. So test number. All right, so test number 1 is gonna cover chapter 1 all the way to chapter 3. So test number 1, usually that one.
Move.
All right, for anything you have to move. All right, test number 1 is probably one of the easiest tests, because if you cover chapter 1 all the way to chapter 3.
Excuse me, Professor.
What's up?
I think you have the ability to mute everyone. So if you can please do that, because someone is, you know, thanks.
All right, cool. That works. Thank you. All right, so test number 1, this one should probably be the easiest test. It's going to cover chapter 1 all the way to chapter 3. Chapter 1 and chapter 2 is pretty much just all definitions. Well, chapter 1 is all definition. Chapter 2 is pretty much how to draw. And chapter 3 is when we actually do mathematical equation. So chapter 1 and 2 should go by pretty fast. Like usually by the end of today, we're probably going to already be done with chapter 1. And we're going to be into chapter 2. Test number 2 is going to cover chapter 4 all the way to chapter 6. So test number 2 usually, probably from my experience, usually the hardest test, because that's where most students do the worst. And then they actually do better for test number 3, which covers chapter 7 through 9. And then test number 4, which covers chapter 10, 11, and 12. But yeah, so that's how we're going to do the test. So each test is going to cover only 3 chapters. All right. Any question in regard to the test? Also for the test, there's no makeup exam for the test unless you kind of tell me early on if you're not going to be able to make it for the test or something like that, if something just happened. But yeah, usually for the tests and for the quizzes, we're going to try to do no makeup for those 2, especially for the quizzes. For the quizzes, there will be no makeup for the quizzes. since for the quizzes are pretty much I dropped the lowest ones. So hopefully you only have to, hopefully you only have to drop one of the quiz and we can just drop the quiz that you missed. All right. So question about the final exam. So the final exam, technically it's able to cover everything, but pretty much for the final exam, it's usually heavier on the last couple of chapters. So it's usually like chapter 9 all the way to chapter 14 is usually the main focus on the final exam. But yeah, like the final exam should kind of mostly focus on chapter 9 all the way to chapter 14. All right. So let's go over exam. Usually it kind of depends. Like once I make up the exam, I could kind of tell you how many questions for each chapter. But say like for test number one, they're gonna be a higher focus on chapter number 3 versus chapter 1 and 2. Because chapter 1 is pretty much just pure definition. Chapter 2 is pretty much just how to read a graph. So I pay more focus on chapter 3. Because chapter 3 is kind of more of a focus on what it is. So I'll let you know once I actually make the exam or once I actually calculate how many problems come from each one. All right. Any other question in regard to exam? Cool. And if you do have a question, you can just unmute yourself because right now everybody is muted, but you should be able to unmute yourself. So yeah, so you should be able to unmute yourself. You could just go to pretty much the bottom and just go to either mute or unmute. So if you do have a question, you can just unmute yourself. Perfect. All right, so for the exam, you're gonna have 75 minutes to complete the exam. And for the exam, I'm gonna give you a 12-hour time period. Was that a question? All right, no question. All right, so I'm gonna give you a 12-hour time period for which for you to go to Canvas and take the 75-minute quiz. So just kind of, well, exam, sorry. So you kind of know once you start the exam, then you have 75 minutes. So you have a 12-hour gap, but once you actually click to start the exam, that's when your 75 minutes is actually going to start counting down. So like for the 12 hour, I'll just say, okay, you have from, I don't know, 7 a.m. to 7 p.m. to take it. And then somewhere in that 12-hour gap, you take that exam and it'll give you 75 minutes. Or if you are a DSPS student, it'll give you a little bit more. But that's how I'm going to be doing an exam. I'm going to give you a 12-hour gap period. And once you start the exam, you'll have 75 minutes to complete the exam. Same thing for the quizzes. For the quizzes, you're going to have a 12-hour gap period. For the quiz, since it should be a lighter material, I'm only going to give you 15 minutes because there's not going to be that many questions as compared to an exam. All right. Any question in regard to exam or quizzes in the 12-hour gap period? All right. And also just know for the exam and for quizzes, for the exam and quizzes is only going to be showing one problem at a time. So once you actually complete that one problem, you're not going to be able to backtrack to it. So once you complete that one question, once you go on to the next one, you're not going to be able to go back to it and pretty much change the answer. Once you commit to the answer, it's going to stay as is. All right, so let's go to cheating. All right, so for this one, if problems from the exam or quiz are found in Chegg, Braille, etc. So for this one, I'm actually not going to do this because I don't want to punish the entire class. But if I do start noticing that's pretty much students are just posting question on Chegg.com or Braille.com. I'm gonna start enforcing this, but for right now, I don't want to just go and just assume everybody gonna cheat. So I'm just assume everybody just gonna use the honor system and not post question on Chegg.com or Braille.com. And I'm just gonna take your word that nobody gonna do that. But if I do start noticing, and I'll post links showing everybody that people are doing it. But if I start noticing people are just posting questions on Chegg.com or Braille.com, I am gonna start enforcing that pretty much whatever problem is on Chegg.com or Brainy.com, pretty much that problem is gonna be taken out, and everybody could receive a 0 for that problem. But for right now, I'll just assume everybody gonna be honest about it, and I'm not gonna worry about any of my test questions being on Braille or Chegg.com. Any question in regard to that? All right, so homework, pretty much for the homework, if you actually go to Canvas, I already uploaded a document, and that document have all of the homework problem. So it'll tell you to do problem like 1 through 15, and you do the odd number for chapter 1.1. So pretty much that's how you want to do it. And pretty much for the book that we're using, it's just the making informed decision with data from Sullivan. So you do want to do this one. And for this one, you do kind of want to get an app. So instead of you uploading like 20 pictures of your homework, get an app where you could take pictures, and that app will just make it into one PDF file versus having like 20 JPEG file. So there are some pretty good apps. So you kind of want to use, I use Adobe Scan, or you could use Genius Scan, because pretty much this will make life easier for yourself and for me. So that way you can just take picture of all of your homework problem that you did on a piece of paper, and then you can just upload it onto Canvas, because that's how I'm gonna be checking for homework. So I just wanna be checking one singular document. So either go to Adobe Scan or Genius Scan or any other type of app that lets you take picture, and then we'll just make it as one singular file. All right, everybody good so far for our homework? And in a little bit, I'll show you where do you want to upload the homework. All right, and also I kind of already mentioned this, all of the lecture notes that I go over and all of the, pretty much the lecture video, I'll post them on Canvas. So in case you do miss class, you can just go to Canvas and you get caught up with the lecture from Zoom, or you could just look at the lecture notes and just kind of figure out what did we went over. All right, so here's the tentative schedule of how or what we're gonna be covering. So if you kind of look at week 1, in week 1, we should get all the way to chapter 3. Oh, sorry, I forgot to say that. Homework is due the day of the exam. So say for exam number 1 gonna cover chapter 1 all the way to chapter 3. So for exam number 1, once you submit exam number 1 on that day, you can just submit your homework for chapter 1 all the way to chapter 3. And it doesn't matter, I don't really have a preference of which paper you use. You can use graph or you can use line. You probably just want to use line, because line paper is probably cheaper than using graph paper. All right, but yeah, homework is due the day of the exam. So roughly right now, you're probably gonna be looking and turning in homework every 2 weeks. So you do wanna kind of be on top of homework, for that way it's not going, like it's not really compiling on. All right, so here's a tentative schedule of like how fast or how slow we're going. But you kind of know this might get adjusted depending on how fast or how slow we're going. If we're going faster, then that means the schedule is gonna go, we're gonna be going above the schedule. But if we're actually going slower, that means, well, we're gonna get behind the schedule. So just know that this is a tentative schedule, but we might go a little bit faster than this or a little bit slower than this. From my experience, we're probably gonna be going a little bit slower than this because I never really could keep up with this schedule. Cool. So the one thing that is gonna stay is the final. So the final is gonna be on August 6th from 7:30 to 9:35 p.m. So for the final, that one is gonna be a little bit different because instead of giving you the 12-hour gap period, I'm gonna give you a 4-hour gap period from this one. So just know for the final, you kind of want to prepare for this one, and you kind of know it's gonna be on August 6th, 7:30 p.m. to 9:35 p.m. So don't plan anything on August 6th from 7:30 p.m. to 9:35 p.m. because you do want to use the entire 2 hours for the final, and you're gonna only have a 4-hour gap period versus having a 12-hour gap period. All right. Everybody good on the schedule, or any question in regard to the schedule? All right, sweet. All right, so here goes some important days. So last day to drop with permission, last day to enroll with a permission number is 6/22/2020. Last day to drop this class without a W is 6/22/2020. Last day to drop with a W is July 26, 2020. The final is gonna be on 7:30 p.m. all the way to 6:35 p.m. But like I tell you, I'm gonna give you a 4-hour gap period. So it should be somewhere close to this. So probably gonna be open from 6 all the way to 10 p.m. All right. Also just know the campus will be closed on July 30th. Well, sorry, July 3rd. So the campus will be closed, but it shouldn't affect our schedule because that's, I think, is like on a Friday, and July 4th is on a Saturday. All right. Any question in regard to this so far? All right. Also, I kind of forgot to say, but for your quiz, you're actually gonna have 2 quiz per week, and the quizzes will be every Tuesday and Thursday. So you do want to be able to do the quizzes on Tuesday and Thursday. So whatever, and the quizzes will always cover what we went over the previous day and nothing more. Yeah. So tomorrow you're gonna have your first quiz. So say like for tomorrow, the quiz we just cover what we went over today. And the quiz on Thursday will cover what we went over on Wednesday. So it will never be anything more or less. It will just be whatever we went over the last class period. So that way you can kind of look at your notes and just see what did we go over, for that way you can prepare yourself for the quiz. Everybody go with that? All right. So up next, we're gonna go over something called test correction. So this is something I usually like to do because, like, I know for students, like sometimes you're not gonna get it the first time around, but it's not really the point that you don't get it the first time around is eventually that you do get the problem correct, or you do get the concept, because the whole thing about learning is like you want to show progression, that something that you didn't learn a week ago, now you do know it. So for the test correction is there to pretty much help you to help you see if now you can actually get that correct. So to do the test correction, like the test correction is where you get the problem that you got wrong in the test, and you see if now you could get it correct, and that's what the test correction is going to be. So whatever problems you get wrong in the test, you're going to be able to do a test correction. So the way the test correction works, pretty much you get the problem that you need to make correction on, and just correct it, and now show me that you know how to do it correctly. So say if you got 2 + 2 is equal to 5, on the test correction, all you have to do is show me that now you know that 2 + 2 is equal to 4. So something as basic as that. So with the test correction, however many points that problem is worth, you're just gonna get half of the point. So say if you miss a question, that question will worth 6 points. If that question will worth 6 points, and now you're able to show me that you know how to do that problem, instead of getting the 6 points, you're gonna get 3 points for that problem. So you get half of the points back. All right. Any questions so far in regard to that? All right. So for the test correction, I do have a form for it, but the thing is, since probably some of you don't have printer, you don't have to print out this form. What you could do on a sheet of paper, you have to make sure that you have that exact same format. So if you have that exact same format, pretty much, yes, you'll get credit for it. So here's a format that I want. So the first thing that I just want the question number. So if the question number was number 5, right here you put 5. Then what I want you to do, so for this one, since pretty much all of the questions are going to be on Canvas, there's not going to be parts to it, so don't worry about parts. So where it says point received for that question, so you tell me how many points you received. So if I give you partial credit, you put how many partial credit I gave you. And then where it says total point the question / part was worth, you put how many points that question was worth. So if it was worth like 5 points, you put 5 right there. So that way I know how much point to give you. So if you got 1 point out of 5, if you do the test correction correct, you'll get an extra 2 points for that exam. Any question on how to fill out this box right here? All right, perfect. All right, so where it says correction, this is where you're gonna put the correct answer. So this is where I want you to just mathematically work it out, or if it's a definition, you just put like the correct answer for that definition question. So where it says correction, you put the correct answer. And then when it says explanation to prove your understanding, I just want you to say what correction did you have to make it correct. So say like for the 2 + 2 is equal to 5 problem, you put like what type of correction do you have to make to finally get the correct answer, that the correct answer should have been, well, 4. So that's how you want to do explanation to prove your understanding. So you just put like, how were you able to correct that mistake that you did for the test? All right. And that's the test correction. So for the test correction, you usually do a week after the test. So once you get the result for your test, a week later, the test correction will be due, and this will be due on Canvas also. All right, any question in regard to test correction? All right, perfect. All right, so that's it for the syllabus. So let me kind of show you Canvas a little bit more, and then we'll be able to go on to notes. All right. So we just went over here with the syllabus. So if you go right below it, it'll say homework, and it says homework math 227 5th edition. So this is for the 5th edition book. So if you actually click on it, it will have all of the homework for the 5th edition. So if you look at 1.1, you have to do problem number 2, 7 through 29, and 39 to 45. So for the 7 to 29, that one's all the odd number. And for the homework, you don't have to write down the question, you have to write down the answer. So I don't want you wasting time on writing down the question. You just put the answer for those problems, and that's it. So for the homework, don't put the questions, you put the answer corresponding to that question. But yeah, so this is all of the homework for this entire semester. So it's for chapter 12, all the way, well, chapter 1, all the way through chapter 14, if we get to chapter 14. But this is where you'll find the homework for each individual chapters and each individual section. Yeah, so you do want to kind of show the work, because like the way that you want to use your homework, you do kind of want to be able to use it that if you look back to it, you should be able to understand what you did. Because if you just have the answer, Well, I know the back of the book have the answers, so if you have all the answer but you don't really show any work, that doesn't really help you out for studying. Like you kind of want to show all of the steps that you did, because stuff that might seem easy to you like today, if you look back on it like on Friday, you're gonna go like, what did I do in order to get that answer? So like for your benefit, you should show the work, so that way you know exactly how you got each individual answer versus like you look at it a week later and you go like, I have no clue how I got that answer. All right, but this is where you find the homework. So anytime we go over a certain section, that means you have pretty much homework for that section. So by the end of today, we should be done with chapter 1. So that means all of chapter 1, like you do kind of want to get started on that homework for chapter 1. All right, but any question in regard to the homework? Yeah, you can use the 4th edition. It really have no difference. I'll upload the homework for the 4th edition, pretty much the same. Only some problems are not there. But yeah, you can use the 4th edition. Any other question? All right, so let's go back to Canvas. All right, so you already seen this, the annotated notes and the YouTube lecture link. So once we're done with today, you'll actually have something there. But for right now, it's empty. So this is week 1. So in week 1, we should get to chapter 1. We should get to chapter 2. And probably most likely we should get to chapter 3. So all of these are all my lecture notes, because this is what I'm actually going to be going over. So once I'm like writing down, pretty much writing on questions, these are where I'm getting the question from. So if you have a printer, you might want to print it out. If you have a tablet, you might want to upload it to your tablet so that way you can write on it. But these are the notes that I'm going to be going over in class. So you have all of my lecture notes. So that way, the only thing you have to do is just write on them, or you just make annotation on them, depending if you have a tablet or not. But these are all of the notes that we're going to be going over, well, for today. So yeah, so right here where it says chapter 1, WLAC.pdf, chapter 2, WLAC.pdf. All of these are the lecture notes. So in a little bit, once I get started with the lectures, these are the lecture notes that I'm going to be using. And right here, if you look right here, this is your quiz for tomorrow. So for tomorrow quiz, this one's going to be open from 7 a.m. all the way to 7 p.m. So you have anywhere from 7 a.m. all the way to 7 p.m. to do this quiz. For this quiz, it's going to be a very simple quiz. All I want you to do is just upload two photos in a PDF file. And one of the photos has to be a student ID. If you don't have a student ID, just get any ID as long as they just have your name and, well, your face on it. So for tomorrow, the quiz, you're going to be kind of getting you used to just uploading picture. So that way for quizzes or for future quizzes and future tests, like you should know how to do that. But for tomorrow quiz, it's just going to be about uploading 2 pictures, and one of the pictures, hopefully you have a school ID that you can just upload, for that way I can see who you are and I can see the name associated to that picture. Yeah. And usually that's how it will work. So right here, since it said week 1, all of the quizzes and all of the tests, if we do have a test that week, will be under that week. So for week 1, you're going to have 2 quizzes. So the next quiz will be the quiz that we take, well, that you take on Thursday, sorry. Yeah. Any question in regard to where to find the lecture note or where to find quizzes? All right. So if there's no any further question, I'm gonna get started with the lecture. Any question before I move on to the lecture? Yeah, so you upload a picture ID and you're also gonna upload a second picture. I'll just leave that for when the thing is. So yeah, so you wanna upload both of those pictures, but the most important thing is by tomorrow, you do wanna get the app that just lets you upload 2 files as a singular PDF file. Because pretty much that's all I want to see if you have the skill to do. If you could upload 2 images and you just upload them as a PDF. So to do that, you want to use Adobe Scan, or you do want to use like the Genius Scan or whatever app that you have that lets you take picture, and then you can just upload it as a single file. All right, any other questions? Yeah, you're welcome. All right. All right, so if there are no further questions, so let me go on to the notes. Screen share. Talk to me after class, because yeah, I can already know if you don't have a student ID, it's kind of gonna be hard. If you don't have a student ID, just get anything that have your name and your picture. If you do get like a driver license, you just block out any like important information like your driver license or where you live, because I just want to see your name and your picture. So if you don't have a student ID, try using, like, if you have a California ID, use your California ID, or if you have like a high school ID, just use the high school ID. If you have a middle school ID, use a middle school ID. But you just need something with your name and your face on it. All right. So far, everybody. Yeah, that should be okay. All right. Everybody is able to see Matt 227 notes chapter 1. All right, sweet. All right, so we got one yes, so I'm assuming everybody gets a yes. All right, so let's go to the. All right, so just remember for chapter 1, it's purely going to be all definition. There's not going to be any sort of math calculation. This is purely going to be definition. So you just kind of pay attention to the word and you kind of know how to pretty much know what does that word signify. All right, so the first word we're going to get into is called statistic. So whenever we talk about statistics, statistic is gathering data set and you're kind of analyzing that data set to make a conclusion about that data set. But usually for the conclusion, you kind of want to make it about the entire population. So you don't want to just make a conclusion about that data set. You want to make the conclusion about the entire population. So whenever we say statistic is just pretty much the idea of gathering the information and then interpreting that information to tell us something about that population. So the next thing we're going to get into is called descriptive statistics. So if you look at the definition I have there, it says descriptive statistic consists of organizing and summarizing data. Descriptive statistics describe data through numerical summary, table, and graph. A statistic is a numerical summary based on a sample. All right. So whenever we're doing a descriptive statistic, it's describing that population, but usually it's just describing that sample. So say if I get a sample, so say I take a sample of 5 students in this class, and I get that the average age is, let's say, 25.3 years. So that will be a descriptive statistic because it's describing that sample. So descriptive statistic is something that describes that sample. Any question in regard to descriptive statistic? All right. So we're gonna go over the process of statistic, and also kind of when we're going over this process is kind of also gonna be laying down pretty much the chapter. So the first thing that we do for the process of statistics is we want to identify the research objective. So this is also called pretty much the hypothesis. So we just want to come up with a hypothesis. So we want to just go like, what are we trying to prove? So once we kind of figure out what is it that we're trying to prove, which is our hypothesis, what we want to do now is collect the data needed to answer that question. And this is something we're going to be going over pretty much in chapter 1. So in chapter 1, we're actually going to be going over different ways that we could collect data set. So, and the way that we're going to collect that data set, we're going to go over in chapter 1. Then what we want to do for step number 3 is describe the data. So the way that we describe the data set is we get a descriptive statistic. So for the descriptive statistic, we actually go over that in chapter 2 and chapter 4. And lastly, what we want to do, we want to perform an inference. So once we get the data set and once we get the data set that describes something, we want to make an inference about the entire population. And for this one, we're going to get started with it in chapter 5 through chapter 8, but we're also going to kind of visit it back in chapter 9 through 15. So in statistics, that's kind of the process that we want to go through. First, you want to identify like what are you trying to research for. The second thing you want to do, you want to figure out how do I collect the data set for that. And then once you collect the data set for that, you want to get something that describes the data set. And then lastly, you make a conclusion about that data set. All right, any question in regard to that? There's really no questions. All right, so if you're kind of like more of a visual person and like little flow chart, you're kind of like a flow chart to kind of help you with that. So this is where you want to start off by. So you want to start by identifying the population. So you kind of want to focus on like who is the population of interest. Once you find out what is the population of interest, and usually capital N just means how many people are in that population. So whenever you see capital N just means how many total people are in that population. Then what you want to do, you want to collect a sample from that population. So once you know the population that you're focusing on, you want to collect a sample from that population. And usually the notation that we use for that is lowercase n. So once you collect the sample, then what you want to do, you want to analyze the sample. And then what you want to do, you want to make a conclusion about the population. So that's the process that we go into statistics. You want to figure out what is the population of interest. Once you figure out the population of interest, you collect a sample from that population. Then you analyze that sample, and then you make a conclusion about the entire population. All right. Any question in regards to that? All right, perfect. So let's go here to population. All right, so for the definition of population, it says the entire set of unit we are interested in studying. The number of unit in the population called the population size is denoted with the letter N, or capital N, sorry. So the population is the entire population that we're interested in. So whenever we talk about population, we're talking mostly about a group. So we're talking about the entire group. When we're talking about a sample is not the entire population, it's a subset of that population. So say if the population, so let's say the population has 1,000, a sample will be if we only collect like 30. So a population means you get everybody in that group. A sample means that you only have pretty much a subset of that portion. So you don't have the entire 1,000 people or the 1,000 object. You only have a subset of that, which the 30 represent. All right. Everybody good so far on population versus sample? All right. So let's go into this example. All right, so say we have a pond, and the pond is this entire population. So that's my population. That's all of the ducks in this pond. So that's my entire population. A sample, so for this population of duck in the pond, how many total ducks do we have in the pond? Cool. So we have 14 ducks in the pond. Perfect. So for this one, we'll say n is equal to 14. And capital N, just remember that. All right. So then this is my sample. Because if you look at it, I don't get the entire 14 ducks in the pond. How many ducks do I get from that pond? 5. So for this one, we get n is equal to 5. So this is your population. And this is your sample. And that's it for the population versus sample. Just remember, population is the entire group. A sample is a subset of the entire group or just a portion of that group. So I don't get all of them. You only get like half of them or a quarter of them or 1% of it. All right. Everybody good with that? All right, sweet. So let's do an example. And also, if you want, you can just speak up. Like, you don't always just have to put it in the chat. You can just say yes or no, stuff like that. All right. So for this one, I want you just either on the chat or either you shout it out. So for this next problem, what we want to do, we want to identify what's the population and we want to identify what's the sample. So it says a agency wants to know the opinion of California resident on the construction of a new road. The agency surveyed 800 residents. So for this one, let's do the easy one. What's my sample?
800 residents.
800 residents.
Perfect. All right, everybody get why n is equal to 800 residents.
That's how many were surveyed?
Yeah, that's how many were surveyed. All right. So for this one, now we want to do population. So what would be my population?
Residents of California.
There you go. So let's say California And that'll be it. So usually for population, population should usually be something that describes your population. So if you look at it, it's not an actual number. It's actually just a phrase or a word that describing that population. So for this one, our population is all California resident. And for our sample size is a numerical value, which in this case was 800. Everybody go for that first example.
Yes.
All right, let's move on down. All right, so up next we're gonna go over something called parameter and statistic. Both of them are pretty much the same thing. They're just little things that kind of make it a little bit different. So a parameter is anything, any numerical value that I extract from the population. And usually if we have a population data set, they usually call it a census data set. So if you ever see in homework where it says we have the census, that pretty much is telling you we have the entire population. So whenever we have a parameter is we get a numerical value from the entire population. So let's say you're my population. So how would I describe the population of my students? If that makes sense.
Your classroom size or your number of students in your class?
Well, let's not focus on the number of students in my class. Like, how would I describe it? Like, can I yet describe it by saying statistics students? Like, would that be my population? Well, I want you to focus on this class. So how would I, because right now, if I put West LA students, that means everybody who's in West LA. But I just wanted to focus on people in this class.
Yeah, you could say that, right?
Say what?
The population that you're looking for is statistics students.
But is this the only class taking statistics for the summer? So like, how can I narrow down to just this class?
Jaime Vallejo's class?
No, statistics students, math 227.
There you go. Yeah, or you can say stats 227 student from 15505. Perfect. All right. So yeah, so statistics student taking it with Jaime. All right, so that's my population. So that's the population. A parameter is any numerical value that I extract from this population. So say I find out from the 45, well, not 45, the 49 students taking this class, say I find that 57% of you are female. So this 57, since I got it from the entire population of statistics students taking it with me, this will be considered a parameter because it's a numerical value that I extracted from the population. So say I also find out from this class of 49 students, the average age, so say average age is 24.7. So this will also be considered, so the 24.7 will be considered a statistic because it's a numerical value that I got from the entire population. So that's what we call a parameter. A parameter is a numerical value that we extract from the entire population. A statistic is any numerical value we extract from the sample. So say instead of me having all 49 of you, I only have a sample of 15. But from this sample of 15, I was able to find that 66.7% of you are female. Oops, spelled female wrong. Female. And we find out that the average age is 23.5. So these two numerical values will be considered statistic. Cuddly statistic is any numerical value we extract from a sample. So since this is a sample of 15, we call this a statistic. But for the first one, since we said we have the entire population of 49 students enrolled in my class, and since 57% of them are female and 24.7 is the average age, this is considered a parameter. So a parameter is any numerical value that come from a population. A statistic is any numerical value that we get from a sample. Any questions so far for that? Did somebody ask a question right now? I couldn't really hear. Melody, you have a question? Okay. Okay. All right. So let's do examples to see if we go with this concept. So for this one says, suppose the percentage of all students in West Los Angeles College who have a job is 84.9%. So for the 84.9%, would that be considered a parameter that came from the entire population? Or would that be considered a sample? Or, sorry, a statistic?
Parameter.
So we'll see. All right, perfect. Yeah. So we'll say that 84.9% is a parameter since it comes from the entire population. Good. All right. So what about the second one? So it says suppose a sample of 250 students is obtained for West Los Angeles College. And from this sample, we find that the average year they've been at West is 1.7 year. So for the 1.7 year, would that be considered a parameter or would that be considered a statistic?
A statistic.
Yeah, perfect. All right, and that's the difference between a parameter and statistic. So it shouldn't be that bad. A parameter if it's from the entire population, a statistic if it comes from a sample. Also kind of like an easy way to think about it, P for parameter, P for population, S for statistic, S for sample. All right, so let's move on to this problem. All right, so let's go ahead and read this problem. So it said the principal financial group conduct a survey of 1,172 employees in the United States between July 28, 2010 and August 8, 2010. And asked if they were currently participating in the employer-sponsored automatic payroll and deduction for a 401k plan to save for retirement. Of the 1,172 employees surveyed, 27% indicated they were participating. The principal group reported that 27% of all employees in the United States participated in automatic payroll deduction for a 401k plan to save for retirement with a 4% margin of error and 95% confidence. So for this one, who is the population? Like, who are they focusing on? So, like, what are they trying to prove? So yeah, so the population should be employee at financial group. And they want to find out how. Yeah. So this is what they're trying to find out. They want to find out like how many of them are participating in the 401k, and the population is employee at the financial group. All right. So for this one, what is the sample?
1,172 employees.
Yeah, there you go. And just remember the symbol or the notation that we use is N. So we say N is equal to 1172. All right, let's do the D. So for D, it says list the descriptive statistic. So what type of information that they give us that describe that statistic? Well, that sample of 1,172. Yeah. So we find out that 27% of them participate. All right. So that's a descriptive statistic. So for the 27%, would that be considered a statistic or a parameter? Yeah, good. Yeah, well, it's a descriptive statistic. So yeah, so this should be considered a statistic. Perfect. All right. Based off of the descriptive statistic, what type of inference or what type of conclusion should we make? Like, do we have a majority of the people participating or what? No, so we have, so we can say we 27. Oops, sorry about that. Yeah, so well, we can make a conclusion. We could say we have 27% that are participating. So if you think that if we take the entire population, do you think it will be exactly 27% of the entire population participating? So instead of getting the 1,172, say we actually go out and we get everybody who, well, every employee in the United States, like most likely it's not gonna be exactly 27%, but it should be something close to 27%. So it might be like 28%, or it might be 25%, but it should be somewhere around 27%. All right, but that's it for that for that last example. Yeah, so like outside or aside from this example. All right. Yeah, so it should, like the 27% should reflect the bigger population, but yes, no, it's not gonna be 100% accurate, but it should be close to 27%. So it's not gonna be exactly 27%, it might be like 25%, 28%, but you're saying like it should be somewhere near 27%. All right, so let's move on to more problems. All right, so for this next one is for the definition of individuals. So when you hear the word individual, individual are pretty much either the objects or the person or the animal that are participating in the survey. So when we say the word individual, it doesn't mean like one person or one object. It just means like who's participating, or what is the object participating? Who are the people participating? So when we say individual, you describe the data set. When we talk about variable are pretty much just a different type of information we extract from the population. So the reason why they call it a variable, kind of if you think about variable, it's constantly changing. So depending on what type of question we want to ask, we're gonna get a different type of results for that variable. So that way they call it a variable because it's constantly changing depending on what question you pretty much ask. So for the next problem, well, any question in regard to individual versus variable? All right. So let's go to this problem. And all we want to do, we want to identify the individual and we want to identify the variable. So let's do the variable. So how many total variables do we have?
Three.
Yeah, cool. So we have 4 variables. All right, so what's one of my variables? Yeah, good. Retail price. All right, what's the other variable? All right, MPG, navigation. So we can say MPG, we'll say navigation, and lastly we'll have please. All right, so those are my 4 variables. What's my individual? Yeah, good. So we'll say individual will be car. All right, good job. Yeah. And that's it for a variable, and that's it for the individual. So the individual is either the object or the person or the animal that we're collecting data set from. And the variable are just the different type of pretty much information we're extracting from that individual. So for this one, like for the first line, we extracted that the car sold was for a core. The retail price was $22,205. The mile per the gallon was 32. The seats were 5, and navigation was no navigation. All right, and that's it for individual and variable. We'll kind of go more into individual once we get into chapter 1.6. But let's get into type of data set. So when we look at type of data set, you're gonna have 2 different type of data set. You're gonna have something called quantitative data set, which is numerical. So that means any data set that we extract from it is something that you can measure and you can actually get a numerical value for. Then we have something which is called qualitative data set, which is categorical. So if any data set that you cannot measure, that just go into particular category or into particular groups. So some example for numerical will be a person height, because that's something that you could actually measure and you could get a numerical value for. Also your weight, your IQ, blood pressure, number of stock of share person owned, how many teeth the dog has, how many pages you read of your favorite book before you fall asleep. So all of those will be considered numerical value because all of those, you can measure them, but more importantly, you get a numerical value for them. Any question in regard to numerical? All right, let's go to categorical. So categorical is qualitative data set. So it says data are measured that cannot be measured on a natural numerical value. They can only be classified into one of a group of category. So some of the example I have, a person's gender, marital status, the hometown you live in, type of movie they like. So all of those are considered category because you fall into a certain group. Like for person gender, you could fall under female, you could fall under male, but you fall into a certain group. The marital status, you could either be married, not married, and you either fall into one of those group, or the hometown that you live in, you fall into a certain type of group. All right, so those are categorical, and that's numerical data set. Any question for categorical versus numerical before we do a bigger example? All right. All right, so let's do this example. So for this example, it says Westlake College is requiring an increasing amount of information about applicant before making financial aid decision. Classify each of the following type of data required on a college application as numerical and or categorical. All right, so for this one, all I want you to do on the chat is just either put N for numerical or C for categorical. So for the first one, high school GPA, would that give me a numerical value or categorical? Wait. All right, everybody put N. Thank you. All right, what about applicant score on the SAT? What would that give me? All right, somebody jumping ahead to C. All right. Gender of an applicant, well, I kind of already spoiled this one for you because we already said that was C. All right, what about parents' income? What would that be? Would that be categorical or would that be numerical? All right, numerical. What about age of an applicant? All right, so this one we're getting slightly mixed, but for this one, it should be numerical. Because for this one, it's something that you can measure, because you can measure age in years or months or minutes or whatever you want to measure in. So for this one, it should be numerical. All right. Any question on why age of applicant is numerical? All right, let's do the final one, zip code. Should that be numerical or that should be categorical? So for this one, it should be categorical. Because for this one, like the one thing that zip code, it does give you a numerical value, but it's not a numerical value that you measure. It's not like when they went to a certain state or a certain property, they went like, we measured this zip code to be 9,011. So the 9,011 or whatever the zip code is, it represents the area that you're in. So kind of same thing like with the hometown that you live in. Zip code will be categorical, sorry, because it pretty much just represents where are you living. All right. And that's it for F. Any question why zip code is categorical versus numerical?
Oh, I have a question.
Yeah, go for
So
it.
what about a review? You know, the reviews that you leave and then they pretty much go from 1 to 5. Would that be, in this case, categorical too? You know?
So you're talking about the review that you go like rate a service or something like that?
Yeah, yes.
For that one, you could take that as numerical because you are measuring like how satisfied or how unsatisfied you are with that. So that one you could put it as a numerical value.
Oh, okay. All right, thank you.
Yeah, you're welcome. Cool. Good question. Any other questions? Oh, sorry, I forgot about this one. Type of social media applicant uses. Would that be categorical or numerical? Oh, you're quick on the button. Yeah, so good. Categorical. Yeah, could either use Twitter, Facebook, Instagram, I don't know, TikTok, whichever one they're inventing now. Okay, all right, so let's move on. All right. So right now we're gonna focus on only numerical data set. So we have a numerical data set. So once we have a numerical data set, we either want to classify it as a discrete variable or we want to classify it as a continuous variable. So the way that we figure out if it's a discrete variable or a continuous variable is a discrete variable is something that's countable. So when I say something is countable, that means you can't get any decimal value. It's something that you could either have 0 of, 1 of, 2 of, 3 of, but you can't really get like a half of it. So if you look right here, I put that you can only get 0, 1, 2, 3, so on and so forth. So an example of that will be like, say, if I wanted to count how many students are in this class today. So for that question, would I ever get like half of an answer?
No.
No, because if we look at how many students I have or participant, it would be 40. Cool. So that's a discrete data set. Discrete data set means that you could count it and it should always give you a whole number. A continuous variable is something that you can measure and it's not always going to fall between whole number. It could fall in the middle of the whole number. So say if we want to get, here, let's do age. Cool. So if I have, say, if I think somebody 29 to 30, is it possible somebody could be between 29 and 30? Yeah. So since there's a possibility that you could be like 29.5, 29.7, this one will be considered continuous. Because you could technically measure it and you could get a more accurate value for it. So you kind of think about it whenever you have discrete data sets, something countable. So kind of think about it. Can I count how many of these things do I have? If the answer is no, then it's continuous. But for continuous, you kind of think about it like, is it possible for it to be not a whole number? If the answer is yes, then it's the continuous data set. So here goes kind of something kind of showing you. So if it's qualitative data set, that's just it. But if it's a quantitative variable, it could either be a discrete variable or it could be a continuous variable. So yes, no, once we know it's numerical, which that's a quantitative data set, you could further categorize it as either as a discrete variable or a continuous variable, depending on how we measure it. All right, so let's do some examples. All right, so for this one, all we want to do, we're going to just classify them as continuous or a discrete variable. So we already know all of them are numerical. So we already know all of them are numerical. But what we want to do, we want to further evaluate it and you see, is it considered continuous data set or a discrete data set? So let's look at the first problem. It says number of children a person has. So for this one, is it possible to have like a quarter of a child? Like, hopefully not. So for this one should be considered discrete. What about household income in the previous year? Is that something that we could actually count their income, or is that something that like it's continuous? If you're pregnant. All right. Well, let's look into the household income. All right. So for that household income, we got some continuous and discrete. For the people who said continuous, why continuous? Well, let's kind of think about it. Like, is it possible for me to count how much money I got in the previous year? But if it's from the previous year, doesn't it pretty much just gonna stay the same? 'Cause it's from the previous year, not like I'm saying this year. So since this can't change, pretty much, kind of think about it, like if I wanted to, you could count every single little penny that you made. So you could say I have 1 penny, 2 penny, 3 penny. So for this one should be considered discrete. And when you're doing these problems, don't overthink it, because that's one of the way that students always kind of like mess up on these type of problems. Like, don't overthink it. Just kind of go with your natural gut. Don't try to go like, okay, what if this happen? What if that happen? Well, cause let's look like even right now, like, is it possible for you to count like every amount of money that you earn? Well, just think about it, like, say we have all of this money. So that's a $1 for the board, how much money do I have on the board? Yeah, so I have $1.27, correct? Perfect. You know how to do addition. Like, is that ever gonna be $1.27 and 5? No. And also, if you kind of think about it, is there a value that go in between 1.27 and 1.28? Like, is there a way that I could like nudge a number between 1.27 and 1.28? Like, no, like it either gonna be you have $1.27 or you have $1.28, but there's no in between. So that way this is a discrete data set because you could count how much money you have. All right, so let's go to C. So for C, it's a daily intake of whole grain measured in gram per day. So what should this be, discrete or continuous? Right. So for this one, this is actually continuous. Good. So the reason why this is continuous, because if you have two different values, so say if I tell you we have 1.27 gram and you have 1.28. So if I have 1.27 gram and 1.28 gram, is it possible? Like, is it possible for it to be in between those two values? Yeah, so it's possible for it to be in between those two values, because it could be that you have 1.27, well, not 0.5 gram. So that's why for this one, it's still continuous. So you kind of think about it, you choose two numbers, you just go like, is it possible it could be in between these two values? If it is possible, it's continuing. If it's not, then say discrete. All right, so let's do D, the amount of time a person spent in a gym in minutes. So what should that be, continuous or discrete? so let's do this. All right, so we got continuous. So this one is continuous. So you kind of think about it, if you have 59 minutes, and if you have 60 minutes, is it possible that somebody spent somewhere between 59 and 60 minutes? Yes. So since it is possible that somebody could spend like 59 minutes and a half, then that's why I consider continuous. Perfect. All right, let's do E. So for E, it says how many times during the week a person visits the gym. Should that one be discrete or should that one be continuous? Cool. All right, there you go. That one should be considered discrete because if you kind of think about it, so say if we have the option of 3 and 4, is it possible somebody visited the gym 3.25 this week? No. So that way this is considered discrete because it's not possible to be in between those two values. All right, and that's it for E. All right, any question in regard to E? All right, good. All right, and for these questions, just keep on trying. Like the whole point of school is to try, and sometimes you're gonna fail. So it doesn't really matter if you fail, as long as you fail and you understand why are you failing on this. So let's go on to the next page. All right, so for the next one, we're gonna go over something called observational study versus a design experiment. So when we talk about observational study is pretty much used observing. That's why they call it observational study. You observe the object or you observe people and you see how do they react. So for the observation, you don't give the individual the TRT. All right, so for this one, I say you don't give the individual the TRT. TRT is just treatment. So whenever we have an observational study just means that we're not giving them the treatment. They're actually giving themselves the treatment. So like an example of that, take like smoking. For smoking, we're not really gonna do like a 2-group and go like one group you smoke and the other group you don't smoke. Usually for that, you wanna do an observational study because you wanna observe people who already are smoking and you wanna kind of compare them to people who are not smoking. So that will be an example of observational study because you're not actually giving them the cigarette, but pretty much they're telling you like, I'm a smoker. So you put them in one group and then you put the other people who say they're not smoking into the other group. So that's an observational study. So you don't give the individual treatment. Whenever we have an experiment, you're actually giving the people the actual treatment. So for this one, we'll put so for that one, we'll say you give the individual the treatment. Right. Everybody good so far on treatment versus observational study? All right, so let's do some example. All right, so let's do part A. So for part A, it says a Math 227 instructor announces a study session to be held the night before a test. The instructor lists the student who attended the session and compared their score to the remaining Math 227 student score. So for this one, what do you think is the treatment that they're giving them? Good. So they're giving them the study session. That's their treatment. But are they telling pretty much who to go to the study session, who to not go to the study session? No. So since they're not telling them you have to go to the study session, you have, or you're not going to go to the study session, for this one, it will be considered observational. So you kind of just look at it. First, try to figure out what the treatment is. Once you figure out the treatment, try to figure out, are they telling them to take the treatment, or are they pretty much just giving themselves the treatment? All right, let's do B. To determine whether a review session will improve the student test score, a Math 227 instructor divided his class into 2 groups. He then required one group to attend a study session and compare the test result of each group. So for this one, we still have the same treatment. The treatment is a study session. But for this one, would this be considered an experiment, or would that be considered an observational study? Good. Oops. Yeah, so this one will actually be considered an experiment. E, perfect. All right, and that's it for B. Any question for B? So let's do C, and then we'll do D. So it says a study took random sample of adults and asked them about their bedtime habit. The research then divided the sample based on who drank a cup of tea before bedtime, then those who didn't drink tea. So for this one, what is the treatment? Cool. So we'll say treatment is the tea. So are they determining who get the tea or who drink tea before bedtime or what? No. So they're not determining who drink the tea before or after bedtime. So for this one, would it be considered observational or would it be considered experiment? Okay. So we get observational. All right, and that's it for C. So let's do D. So it said a study randomly assigned volunteer to one of 2 groups. One group was directed to use social media site as they usually do. One group was blocked from social media site. So for this one, what is the treatment? Perfect. So the treatment is social media. No. Social media. So for this one, are they forcing people to use and not use social media? Yeah, because if you kind of look at it, it says a block from social media. So for this one, will be considered a experiment. Cool. All right, and we're done with D. Any question in regard to D? All right, so let's move on down. All right. So I think we're going to a word called confounding variable. So confounding variable, when we're trying to show there's a relationship between X and Y, but they're actually a third variable. And that's the reason we're seeing there's a relationship between X and Y. So in this one, I'm telling you the X is the activity level. So you're saying how active a person is. And for our Y, we're saying weight gain. So we're saying if you have an activity level, so probably if you have like a high activity level, you don't have that much weight gain. But if you have like low activity level, that means you have a high weight gain. So we're trying to show that this causes that. But other reason why we might be seeing like weight gain is your age. Because you kind of think about it like the older you are, the lower your metabolism rate is. So that could be the reason why you're gaining weight. So not totally just activity level. There's the other variable that contributing to the weight gain. So that's what a confounding variable is. When we're trying to show there's a relationship between X and Y, but there's actually a other variable that contributing to that response. Any question in regard to confounding variable? All right. So one thing that you do want to be wary of, because if you have an observational study versus an experiment, usually for observational study, so one of the questions on the message board, on the chat board is, are confounding variable considered inaccurate statistic? It could lead us to an inaccurate statistic because we could say there's a direct cause and effect between, kind of think about it like, say if I tell you if you drink this pill, you're gonna lose weight. So you drink the pill, you think you're gonna lose weight, and you think you're gonna lose weight because other people have lost weight, but a confounding variable could be that those people lost weight because they also exercised, they started eating healthy. So it's not just the fact that they're taking that pill, it's the fact that they're taking these other factors or other variables that are contributing to losing weight. So it could lead to an inaccurate statistic because we could think that this one X variable is contributing to the Y variable. So it will lead us to like a wrong conclusion. Right. So you kind of know whenever we're doing an observational study, we can, so say we can do cause and effect. So whenever we're doing an observational study, we can't really say there's a cause and effect because the bad thing about observational study, people have to self-identify and they have to self-identify themselves and put them into a certain category. Kind of going back to like the one about do you smoke or do you not smoke? Because if we're doing an observational study for that one, pretty much we have to kind of rely that people who are telling us that they don't smoke, that they really don't smoke. Because if somebody don't smoke, say they don't smoke, but they probably don't smoke like as heavy as somebody who does smoke, but they still smoke, that could kind of contribute to a misleading information. So whenever we have observational study, we can't really do a cause and effect. You can only do that for the experiment because with the experiment, you could do a random selection. So usually for a random, for an experiment, we could say there's a cause and effect. But usually for an observational study, we usually don't want to say there's a direct cause and effect. Because for an observational study, they're more likely a chance that they're confounding variable in an observational study versus in an experiment. Because at least with the experiment, if you have random selection, and that's something that we'll get into when we get to 1.6, if you do a random selection, you're kind of avoiding that confounding variable. Any question in regard to that last one? All right. So what we're gonna do, we're gonna stop here. We'll say stop. And we'll get started on June 16th. All right, so we're gonna stop right here. So we're not gonna get into 1.3. We'll get into 1.3 tomorrow. So let's stop the share. And that's it. All right, so just to let you know, for tomorrow, you're gonna have your first quiz. For the first quiz, pretty much all you have to do is upload a picture with your first and last name. So if you if you have a school ID, just upload that. If you don't, you could do a driver license or California ID license. Just make sure to block out like your driver license number and where you live and any of that information, so that way I won't have it. And there's also gonna be a second picture. So also just find an app that, because there's like the app that I told you to do, Adobe Scan, the Genius Scan. It'll let you take like many different pictures, and then it will just upload it as one singular file. So I just want you kind of to get used to that. So that way, for the test and for quizzes or for future quizzes, you know how to do that in case I do ask you to take a quiz and stuff like that. All right. For the second picture, I'm gonna let you know for the second picture on the quiz. Cool. It's pretty much the second picture is just gonna be kind of like a selfie or something like that. Oh yeah. Yeah, so for tomorrow, the quiz is gonna be uploading two picture, and more importantly, I want you to upload the two picture as one PDF file. So that way, for future tests and future quizzes, I know you have that ability for that. No, well, you're gonna get graded, but I'm not gonna give you like a bad grade because you took a bad selfie. So everybody's selfie will get a perfect grade as long as you attach it as one singular file. Yeah, so either do a Genius Scan, Adobe Scan, or whichever other scan you could think of. But yeah, there should be something on your phone that will let you take a picture, and then it'll convert those pictures into a singular PDF file. All right, so that's it for today's first class. One class down, pretty much 8 more weeks to go. Any questions before I end this and start uploading all of the files and the Zoom lecture? All right, cool. So if no further question, I'll just end the meeting. Thanks everybody for joining me today. I'll see you tomorrow.
Thank you.
Thank you.
You're welcome. All right, thank you.